This is Ganesh Gowtham. I have 20 years of an industry experience, worked in various fintechs and corporate and investment banking. Today, I'm going to share some of the best practices followed in some of the banking industry. Okay, so let me start with a question. So how many of you guys really read a blog of Uber engineering? Raise your hands. Uber engineering? Probably Netflix or Airbnb in the medium.com. So if you read those articles, you will come to know how they develop a solution, okay? So an enormous number of solutions were developed by them. But did you ever saw any of the corporate companies or investment banks openly share the intellectual property of how they develop web applications or scalable, reliable applications? So today I'm going to take an opportunity with my 20 years of an experience to give you a blueprint of how the money movement happens in any given corporate and investment banking. That's a session all about. And let's go for an agenda, okay? So agenda is all about navigating financial turmoil and what's the various crises happens and how bank is not just about the scale, okay? So how we safeguard our all revenue and the liquidity within the bank is what we're going to talk about, all the measures. So going forward, we're going to have some design patterns and NFRs to start with, okay? Testing strategy or performance testing or chaos engineering techniques and profiling techniques and things like that. And last but not least, I'm going to explain you the pain point faced by any of the bank operators of back office operators that you can correlate with any of the front desk or any of the operators in your company. And I'm going to explain about how we can improve the efficiency of an operators using a micro-frontend, using a generative AI solutions and machine learning techniques. Okay, so what is banking all about? Is banking all about debiting and crediting like what you see in in the area of a career, like exit transaction type of a thing? Absolutely not. So can somebody please explain me about, do you know about the nitty-gritties of what what exactly goes behind the money movement in any given bank? Can you guess how many controls were in the place? Can you guess various options that are available in our module? Let's take an example that we have bank, apart from what we compete with the fintech, but it also about the regulatory and requirements and proactive checks and mission critical controls. So let me deep dive into, this is nothing to do with the Wells Fargo, this is an industry standard pattern that we follow in any of the banks. So let me take an opportunity to explain these things. These are all called origination channels, which means that clients can initiate a payment through the web. Take an example of SBI.com or online SBI.com. Or like mobile, like SBI Yono type of a thing, and it's an API. This is something which is interesting, which is CRM. Let's take an example that we from Wells Fargo or any given financial entity expose an API, but for some reason our clients don't have a budget. We technically wrap our API into their CRM solution, and end of every single day we technically get an So we technically get all the feeds and then process it. Let's take an example of the whole end-to-end money movement or a fund transfer which happens in any of the corporate company. Okay, so these things are technically split into 3 different sections. To start with, we say initiation, execution, and gateway. Okay, the first validation is nothing but predominantly that it is an UI validation type of a thing. Second one, whatever format that we get, we convert that into ISO 20022, which means that in subsequent slides, I will explain you what's an advantage of converting all the industry standard format into one format so that we'll be able to explain more about that. And the payment smart routing is all about based on when the client gets onboarded into the Wells Fargo or any given company, we basically get some characteristics about the client. Based on that, we would be doing a smart routing. Let's say, take an example. If it is a T1 or T2 or T3, which means the real-time payment or future data transaction, and the mode of the payment, we technically redirect that whether it is an NEFT or RTGS or a UPI or IMPS type of a thing. I'm just giving a context of in India so that you would be able to easily correlate. And every time we get a request, we technically acknowledge. And the middle one is all about the business validations that we do for any given payment trail. Take an example that. For any given payment trail that we process like RTGS, probably have some business validations in the place. And then at the same time, when the client initiate a payment, let's say, for example, Walmart is trying to initiate a payment for a Google, okay, for one of the payment trial, and we say that beneficiary account is valid, or they have an IBAN number, they have an IFSC number, and things like that, valid or not, is what something which goes into this particular validation. And the fraudulent check is nothing but when let's say, for example, Google is transferring your funds, we check that the beneficiary is in some of the fraudulent transactions and things like that. This we call it in United States as a OFAC filter. So any terrorist attacks and all these clients and CIBIL rating, all these things would be basically mentioned in the fraud checks. And we have all fund control in the place, so all the liquidity controls of the banks on all those things much before we transact, all those things in our fund control. And tiering is all about, so whenever we do a transaction, we also do a tiering based on certain aspects of the things. We prepone based on some of the, so based on some of the based on some of the clients, what we do technically, we tier the transaction and redirect it into a highlight or a platinum customer tunnel type of a thing. We use a Kafka channels for that. Predominantly, you see that Kafka, Elasticsearch, Redis, and suite of all those SRE tools, and technically they were used. And then once we technically translate all our data to the clearinghouse, we have various payment solutions here, like clearinghouse, RTP, and things like that. Based on the cost-effective channel, we technically redirect everything to one among that. And network connectors is the one when it goes out of our bank, we convert to the industry standard format again. That is what is a network connectors and things like that. So now we had seen the high level of a payment application. Now we see what are the checks and balances in the bank, right? To start with. So as I said, we have something called, industry standard is something like a command center. You can think like a command center, like is like, technically like an LCD screen type of a thing here. And then you have 24/7 payments, inflow and outflow, all the payments would be monitored right on the LCD screen here. So that's an advantage of having the command center here. Sorry, extremely sorry. Please apologize for that inconvenience. So as I mentioned, command center is like 24/7. We have operators watching, every single payment within any given bank, and any inbound and outbound payment which is stuck. Technically, operators would be able to see right on the LCD screen and take an appropriate action. So that is the first control that any given bank might have. And the second one is a control layer. So probably you know what is JSON and you know what is regular expression. I'm gonna do a magic with these two. So let's take an example that I said that we are converting everything to the industry standard format here. So guess what? During the crisis situation recently happened, do you know how many banks went bankrupt in 2024? Guess the number. It's 5. I don't want to name, but it's 5 up until like 4 months or 5 months back. Okay. So this was a challenge given by our CEO to us. Okay. Guess what happened? All the inbound transaction, outbound transaction, future data transaction, and things like that were technically put on hold with a simple kill switch, which is a combination of JavaScript as well as the regular expression. That is the power of control layer that was technically built in Wells Fargo. Any questions on control layer? So with this, we would able to technically stop the payments from source to destination based on maybe a country, maybe an account number, all toxic combinations of the properties of the beneficiary, we would able to control within no time. So this is how any of the banks would able to control the liquidity of a bank during the crisis situation. So this is like a pipeline. You can think like this is like a pipeline, and this is one of the modules which is technically plugged over there, which intercepts everything. Since the good advantage of converting everything into the industry standard common format, so that I would be able to apply all the regular expressions on the fly. Let's say, for example, during the Russia-Ukraine war, I can say stop all the payments to the Russia with a flip of a button, and I would do the release. I just do the UCD release or a harness release, a properties file change, and then bounce my server. I am done with that. And now above and beyond, we also have a solution in the place with a Redis type of a thing. We periodically refresh the cache as well, and then we onload, we preload the cache on demand, like, something like that. Sorry? Oh, sorry.
Does the control layer app also have access to the command center? let's say, for example, if a fraudulent transaction is coming and you are identifying it at the start itself, how do you tackle it?
So what type of fraudulent transaction you meant to say? You meant to say security penetration, that type of fraudulent transaction, or anything with respect to the
security or sudden spike in the volume of transactions.
Those things would be, this is something which is technically a business layer type of a control check. The one which you are telling, the fraudulent transaction, things like this, is entirely different. I will explain in subsequent slides.
One question. The control center, you said the system everything in the monitor. So is it a manual thing or is it automated?
No, control layer in any given bank. So all the solutions in the bank is technically automated. The one which, the command center is the one which normally we see on the screen is something which is not automated, because you see the numbers over there and the operator would technically take an action literally on the numbers which is shown. So we technically,
Number of transactions in a day or
it is basically an aggregated number would be shown over there, like Grafana type of a thing. Okay. So let's take an example, future data transaction for the NEFT. So NEFT is all about the spins. Okay. After 6 p.m. or 9 p.m. you won't be able to do NEFT because it goes for a standard instruction for next day. Okay. So let's say, for example, you wake up at let's say 6 a.m. or let's say like 4 a.m. and check the command center. It says that few crores were technically in the warehouse. Okay. And then let's say, for example, when the spin starts, you literally has to see a downtrend of the 10 crores to 1 crore, few lakhs, and then it should be near real time or a batch size, something of that sort. So this is an industry standard. You can refer in some of the articles. I can share that Wikipedia articles of all those things where I scraped this information. And this is something that, most of your applications might have, that every single day frequent checkouts you have. So in bank, we don't have frequent checkouts, but we call it as a penny transaction because we do 0.01 cent every single, minute to say that all our systems are technically flowing through or not. So normally you might have seen a canary transaction or a canary process or a health check in the spring actuator type of a thing, where it just says, services are running or not. But here we technically do it every single minute. We do 0.01 transaction on demand if we need. This is like with a penny transaction type of a thing. And this is also an industry standard. And bank sometimes you develop a solution. Let's take an example of having an LinkedIn post. Okay, what happens when the gentleman posted a LinkedIn and you miss it? One of the message in the Kafka is missed. Not a big deal though, but in bank it's a big deal. Every single payment message, if you miss, regardless of the amount, is a customer impact. Okay. So now we have suite of applications and processes in place when something goes down, and we have something called recovery services, wherein we would be able to replay all these transactions by the help of operators. So that's what is recovery services and things like that. And last but not least, you are well aware of alerts and notifications. Okay. Now let's go to this one. Stable and reliable banking applications. One of our pet peeves. Subsequent slides are everything is technical. So how these applications are developed? Is it because we develop a solution from the get-go in a very optimized way? And you know the answer for that. I don't need to explain. Is it because of adherence of a design pattern? Or is this because of NFR or testing practices? Just we'll see that. Okay. The first and foremost of the SDLC, the life cycle, is a development that we know. And the second one is nothing but we do the unit testing, and then you do integration testing, and we do the functional testing from the UI if there is a user interface exists, and we do mocking and things like that, followed by we do penetration testing. Okay, and everything is done and dusted, and then we put that into the UAT, and we do the performance testing. And then in any given bank, we go with the baby steps. Okay, we test the services with one user. Okay, things are working, and we test this the same system with 10 or few concurrent users with a different ramp up time. We predominantly there are too many tools, but I'm very much familiar with the JMeter along with the Blaze meter, so which is deployed on the Kubernetes pod. And then technically we see all these average throughput, errors, and average response time and average bandwidth, and technically every single thing is being calculated over there. The first one is all about identifying a bottleneck. So this is all regression test cases normally would be configured on the Jenkins every single day for every single check-in using a Git hook. So whenever you check in the code, there's a Git hook which is configured and it gets triggered, and Jenkins is triggered, and this Blaze meter scripts would run and send the results periodically to our email boxes. And we identify the bottleneck, and Thereby we see whether it is scalable or not. And then, based on that, we plan for a resource utilization, and then capacity planning, and then, throughput. If there is any error, we technically, try to reprocess and, whole of the performance testing. Now that we found that, let's say, for example, my requirement is all about 1000 TPS and I'm getting only 500 TPS. I need to find out where exactly is the problem. Okay. There are multiple techniques that we can follow to find out the bottleneck, but my best gut feel says, we go with a JProfiler or similar profiling techniques to find out where exactly is the problem. The first one is about, whenever we do the memory testing, what we do, we just start a service, and then we wait for a couple of time, and then we find out how many objects were created on the memory, and then we rerun that one and try to compare and contrast between, these two runs and find out if there is any issues with that. And we find out whether and then what we do also, we also do a concurrency testing as well, because we had faced multiple issues with the, very bad development practices of the global variables and things like that, which is shared across, many actions. So these things would be found with the concurrency of profile testing. And then we also do, since most of our applications are external facing applications, we do the penetration testing using the Burp tool or Wireshark as well. And then with that, we simulate, there's a gentleman who asked about DDoS attack type of a thing, and quick flurry of a request, outburst of a request and things like that, with a malicious intent of SQL injection, things like that. So we have a suite of test cases. We try to break our system purposefully because it's a bank. End of the day, it's a trust, and we deal with the people. And then we also use code coverage tools to find out, all the, everything is really covered or not. And we use TrueCover for that. Okay, so it's a question. So now we have seen the techniques which makes our application stable enough. How to make sure that applications are reliable enough? Guess what? We use this particular technique. Does anybody know or familiarized with these techniques? Any? So what we do is we take an application which is stable enough. Now assume that we are in the phase that it is stable enough, and then we use chaos engineering techniques to find out whether it is reliable enough or not. Okay. Take an example for any given application. We have a suite of test cases. Let's say we take an application which connects to the database, which connects to the Redis, or any of the given downstream and upstream systems, and let's say all different diversified distributed systems, API, MQ, and let's say for example file store and things like that. Okay, we come up with a suite of test cases to break this. What happens when MQ is down? Would we be able to process? What happens when Kafka rebalance happens? What happens when one of the broker goes down? What happens in the Mongo when the primary node goes down and the secondary becomes primary due to the election algorithm? 5 to 6 seconds it is idle. How to simulate these conditions? In one of the use cases I mentioned, real-time payments is supposed to be like UPI. It should not be down not even single second. That's a requirement of any given bank. Nothing to do with the Wells Fargo. It's a US Fed thing. Okay. So how we make sure all those things is because of this one. So let's take a simple use case of a simple flowchart. As I mentioned, now we have a suite of test cases documented, and then we run our experiment. So when we run our experiment, this experiment can be successful or failure. As I said, I'm a big fan of doing something in the baby steps. In the chaos engineering, we call it as a blast radius. So we do an attack or assault in a very simple single component. If it is working, then we increase the blast radius. Take an example that if you want to have an assault on API controller layer, if it is working as expected, then you can go for a service layer. In the service layer, technically you might connect to the Redis or a database and things like that from Red, okay, something like that. And then if it is working, you increase the blast radius over there, which is nothing but the green one. And let's say for example it is failure, then we find out why the heck it is failed, and we try to fix that and again rerun that one. Okay. Now that said, let's see what type of different assaults that we can do. The first assault which we can do is an application failure, which means that in an application we technically try to have an assault, which means that we purposefully try to increase the memory and see what is the behavior of an application. Is the request and response we would able to get within a SLA or not, or there is a latency in the API. And let's say, for example, the same thing like, when you increase the CPU, what exactly is the behavior? And the same thing with the disk. Let's say, for example, we purposefully increase the disk size and see whether, the auto archiving jobs are archiving all the logs or not. Something of that sort is really working or not. At the same time, when the disk space, when we increase, we also see whether our Genius alerts or, elastic APM alerts or systematic alerts are triggering or not. These things we systematically verify. And network IO. Let's take an example that you have an, whether it's a global load balancer or a local load balancer. When you have an attack on, when we say that, network is busy, is the request technically redirected to a secondary data center, or the request is redirected to one of the hosts on the primary data center, is what we check. And something which is interesting is an exception. So it is a generic, it's not just a generic exception. We throw Kafka exception, and we also throw something related to Mongo exceptions and things like that, and see what is the behavior. So some of the use cases would be like, when we are not able to get the information from the database, or database is down, we technically try to get something from the Redis. Is those services working as expected or not? Those things are verified using an application, failures here. On the contrary, we have something called, infrastructure failures, where the same thing on the infrastructure is performed using a tool called Gremlin. Here we technically use something called Spring Chaos Monkey over there, and here we use Gremlin, and we have an industry standard thing. And the way that we automated everything is with a Python Chaos toolkit. So it is something like, it helps you to configure all these things in a CI/CD pipeline. Okay, here it's exactly the same thing what I had mentioned. These are some of the attacks that you can think of, we would be able to do with the network and see. This would be more efficient if you have something on the PCF where you can bring down one of the node in the space, or you can bring down one of the node in the Kubernetes pod and things like that, and see whether it would be able to spin off, another pod in the very quick succession or not. Such type of things you would be able to do with chaos engineering. So let me take a pause if you have any questions here. Happy to answer if you want. Yeah.
How do you simulate the broker being down? So all those use cases is down, because you may not have.
If you have, that's a very good question. If you have an access to, the Kafka broker itself, right? You would be able to do that. Is a no-brainer job. Okay. But however, in most of the corporate companies, you might not have an admin access to do that. That's a limitation set unfortunately for the developers. So what happens when the broker goes down, you get a sort of an exception. We try to simulate that exception using the application level failures. So that's the same thing, or whatever infrastructure failures, like in the Kafka rebalance and partition, things like that, you're going to get some sort of an exception, and we try to simulate that exception using an application level failure. So now this is one of the interesting things that I want to talk. Probably every day in and out, some of the payment would be stuck for us, and then we call an operator. Wonder that except the extreme frustration, do you guys ever thought what exactly happens behind the scenes of a bank operator? Can somebody guess and tell me at least one or two things which they might be doing? Guess, no problem. Don't want to guess?
Checking the log. As we are debugging and checking the logs, they will be checking their transaction logs somewhere and
Okay. So now I call a customer care and said that, I did an NEFT, but, the beneficiary didn't get. And what you said is, like developer check the logs and they check an application. In spite of that, it takes a lot of time, right? So let's see what exactly going on, in a very empathetic way, right? These are all the things, some of the things which might be going. Let's take an example that, they might have, they might have an KYC application. Maybe your payment might be stuck because the beneficiary might not have been completed in KYC check, example. And because of this, they will be doing KYC, and then they go to an online SBI.com, and merger and acquisition, they might have n number of application, and context switching is very hard. Okay. And second, at the same time, they would be having an operator call, and then you probably would be yelling at them because, you need to run to office at the same time, right? You are a person with 0% patience probably, or the operator are not responding in the way that you want them to be responded. Okay. And they need to identify a solution. You might have seen that, hey, you know what, can I put you can I put you on a hold? And then they would be connecting with, suite of operators or senior person to find an option how to solve the problem. At the same time, they would be monitoring, in a traditional bank, apart from this, they would be monitoring other payments and things like that as well. And these are all the things, and which technically goes beyond the scenes. Now, having said that one, this all the things goes beyond the scenes, and then this is an honest attempt that I want to put here. It is nothing to do with the Wells Fargo. How can we improve the efficiency of an operator, right? Regardless whether it's a bank operator, whether it's a front desk operator, whether it's an operator at the big bazaar, regardless of that, we're going to talk about certain things that can improve the efficiency over there. So let's take an example that this is an application. So you have application like KYC, which is a different application, and you have like online SBI.com, and you have other applications, things like that. And the context switching is very hard. So one of the way that we can solve this problem is put all these applications under one umbrella in one single pane of a glass using a micro-frontend strategy. How many of you guys are aware of, we know Angular, we know Vue.js, we know React.js, and we know plain vanilla flavor of HTML. Because over the period of time, if you don't have a discipline around, the common layer of how the UI has to be built, over the period of time, somebody from a different company, well-versed, give an opportunity, gentleman would be creating an Angular. I would be creating React. The good part is when you use this micro front-end, you would able to, expose everything under one umbrella using an, federated plugin, which is called federated plugin 5. So with that, you would able to, regardless of the technology, you would able to embed everything in a single web application. Guess what? Navigating from one application to application without even opening a tab, you would able to achieve using a micro front-end. And one of the advantage what we can do here is because everything is a JavaScript, okay? The information about your search history, let's say for example, the gentleman called an operator in the SBI.com and his account number is 123 and the operator searches 123 and in the KYC and then immediately go to an online SBI.com. Since everything is a micro front-end, the fact that I search 123 is in my Redux store. And then I have a simple pub/sub model would able to retrieve the fact that I had searched 123 and then it automatically searches the details into my online SBI.com. Thereby, I would able to save one click over there and there is absolutely no context switching over there. The fact that I searched about the gentleman configuration account number 123 would automatically be retrieved over there. So we have achieved this one using simple Redux concept in a micro front-end.
How do you maintain the sequence of the messages? Because
let me complete the flow. If you don't mind, I'm happy to explain the offset values and strategies followed over there and duplicate checks and things like that in the Kafka. Yeah. And so this is what happens and all the payment repair and things like that would be handled here using a micro front-end. Since so many applications are integrated under one umbrella, we also introduce something called a pub/sub model. Let's take an example when this particular application is rendered. Using a React properties, we would able to send all the information. Upon receiving that one, let's say for example, if they need an additional information, we would be sending that information using a pub/sub model, almost like a Kafka we had simulated. So with that, they would able to improve the efficiency without the context switching over there. And we also introduced something like, you see a bot type of a thing. We had introduced a bot. So let me take an example that I said few minutes back, the operator puts our call on the hold. The reason why our operator put our call on the hold because they don't know how to, respond to you. In other way around, or the information required for him or her to fix the issue is scattered across many places. Let's take an example. In your company itself, you use Confluence, you use Excel sheet, you use PowerPoint, something in the mail, and we don't have a discipline to put into a store over there. Likewise, the operator technically face all these issues. So what we had done is, we had created a generative AI chatbot, which retrieves all the information of the standard operating procedures and then would be able to respond. The beauty of this particular micro front-end and this particular chatbot is traditional chatbot works on a context. Example, if this payment is stuck, I go to a chatbot and say, hey, this payment is stuck because of error 1 or the beneficiary number is missing, how to fix it. The beauty of this one, the combination of chatbot and this JavaScript is the fact that I open an investigation web page and then I see that something is stuck. I know that why it is stuck. Let's say error message. Let's say something which is in the red color. That piece of an information would automatically cascade it to this particular chatbot. With that, I don't have any pressing need to even send that information to my chatbot itself. As soon as I open a screen and it says that something is missing, and I would able to retrieve that information automatically from my chatbot. I don't need to even type that. Thanks to the JavaScript Redux and the user context and entitlement and persona which is built, and all this information would automatically cascade it to my chatbot over there, and chatbot automatically displays the relevant details along with all the citation and things like that. The second thing that we can do, as soon as customer calls, we know about their number and the number is stored in our inventory. What we technically do is we technically surface all the old case statements which are not fixed, and I immediately will respond saying that, hey, I think you are calling for this one and this is not responded, and I am happy to respond. Did you call for the case number 123? That was implemented few years back itself. Now what we had implemented is, if a gentleman calls and yells at us, and we also interrupt all those information and convert this voice to text, and we do the identity information about an emotions as well. And then guess what? We immediately surface, with the use of all LLMs, we would able to surface some of the rewards for them based on the context why they had called. So thanks for all the recent LLMs in the place, we would able to convert not only the voice to text, and we would able to on demand able to identify emotion of a customer on demand on the fly. Everything is integrated within this particular one portal, which technically improves the operational efficiency. Last but not least, let's say for example you have all the payments which is stuck, and then we know that why it is stuck and we fix that payment. Over the period of time, there are LSTM based machine learning algorithms in the place. We know that, hey, this is the payment which is basically stuck and this is the payment which is fixed, and then we know we compare and contrast both, and we have machine learning models. Since we are bank, every single thing has to go to maker checker, and we had implemented. Combination of all those things, technically it improves the operational efficiency of a bank operator. Thanks for giving this opportunity. Thank you.